This is lesson 3.5, squares and square roots. Let's think about the relationship between the area of a square and the length of the side. Now, we've talked about this before. The area formula for a square is side times side. So, for example, let's say that this square is 36 centimeters squared. So that means it would take 36 little centimeter squares to cover this particular square that I've drawn. If I know that the area is side times side, then I can actually write it as area equals side to the second power, or side squared. Remember, this is to the first power, and then you add the exponents. So I'm really asking myself, what number times itself gives me 36? And the answer is 6. So each side of this square would be 6. And what we actually did was we took the square root of 36, and that's what we're going to get into today. So again, the area is 36 square units. I made mine centimeters, and the side length is 6 centimeters in this case, because 6 squared is 36. So here's some definition work. A number that when you multiply it by itself to form a product is the square root of the product. So that's pretty wordy. What it means is if you take a number, 7 for example, really? Ooh, I can't control this. Let's try this again. If I take 7 squared, which is 7 times 7, that equals 49. And if I then square root 49, that equals 7. So a number, when you multiply it by itself, here's that product, and that number is the square root of that product. So 6 squared is 36, and the square root of 36 is 6. When you take the square root of a non-negative number, it's the inverse of squaring the number. Remember, it undoes the operation. Addition and subtraction are inverses. Multiplication, division are inverses. Squaring and square rooting are inverses. So if I have 8 squared, we know that equals 64, and the square root of 64 then equals 8. All right, every positive number has 2 square roots, one positive and one negative. Here's the radical symbol, and it indicates the non-negative or the positive principal square root. And then this symbol, negative square root, is used to indicate a negative square root. For example, I can have the square root of 81, and I would say that that's 9. If I write negative square root 81, then I want to make that answer negative 9. If they're asking for 2 square roots, and some of your directions will say that, if I have the square root of 25 and it asks for 2, then I can use this plus minus symbol right here. I know it's positive and negative 5. And this is the case because I know up here, let's backtrack a little, 9 squared is positive 81, but also negative 9 squared is positive 81. So it does work that we get 2. Let's jump down to this little cautionary box down here. The square root of negative 49 is not the same as the negative square root of 49. You cannot take the square root of a negative number, because there is no number that when you multiply it by itself that'll come out to be a negative. Any number times itself will be a positive. These numbers right here, 16, 36, 49, etc., are examples of perfect squares. So a perfect square is a number that has integers as its square roots. So for example, 1 is a perfect square because the square root is 1. 4 is a perfect square because the square root is 2. 9, the perfect square, its square root is 3, etc. What we're going to do on the next page is make a table of perfect squares. So I want you to write this down. You've got your perfect squares. And once I'm done making this table, I suggest you pause the video and write this down. It's very important. So I know that 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, 13 squared is 169, 14 squared is 196. Notice all we're doing is reversing the last 2 digits. That's kind of cool. 15 squared is 225. 16 squared is 256. 17 squared is 289. 18 squared is 324. 19 squared is 361. And 20 squared is 400. So all of these numbers to the right are the perfect squares. And the numbers to the left are their square root. And by to the left, I mean the 1, the 2, the 3, the 4, etc. Not the 4 squared, but the square root is actually the 4. Alright, let's do a few examples. Here they're asking us to find the 2 square roots of each number. So 64 is just positive and negative 8. 121 is positive and negative 11. 25 is positive and negative 5. And 144 is positive and negative 12. Piece of cake. If you need to use your table for some of the larger numbers, go ahead, but try to memorize them. It's going to make it a lot quicker. Okay, simplifying each expression. The first thing we're going to do is the addition that's underneath this radical sign. So 32 plus 17 is 49, and the square root of 49 is 7. They're not asking for 2 square roots. They're just asking us to simplify this. So we're just going to make it 7. Square root of 73 minus 48 is going to be the square root of 25. And we know that that answer is 5. Here I have 2 times the square root of 64 plus 10. So the first thing I have to do is take the square root. Technically, when you take a square root, it's to the power of a half. So that's why we do that first. We do it as an exponent. So the square root of 64 is 8 plus 10. 2 times 8 is 16 plus 10 is 26. There's 2 different ways that you can do this problem. You can take 196 divided by 49 and you get a 4, so the answer is 2. Or the square root of 196 is 14 and the square root of 49 is 7, so I still get a 2. So either way is acceptable. And then finally here we have 3 times the quantity, square root of 144 minus 6, so we have to work in parentheses first. Square root of 144 is 12 minus 6, so that's 3 times 6, which equals 18. Make sure you get all these examples down. And I believe this is the last one. It's an application, computer application. The square computer icon contains 676 pixels. How many pixels tall is an icon? You probably know this. I'm a little old school, so pixels are still new to me, but these are little squares up here. So the little colored dots make up the picture, and the dots are called the pixels. So it says the square contains 676. How many pixels tall? If we look at this as a square, then I can look at that as the area. That's how many little dots cover it. So then I know that my area, which is side squared, equals 676. So the inverse operation of squaring is square rooting. So I know that my side equals, in this case it's going to equal a 26 pixels. And the way that I got the 26, it's sort of by, if I wasn't using my calculator, then I would have to just kind of do trial and error. I know my squares on my table up to 20, so then I would try a 21. But 21, I know that 1 times 1 is 1, so this is going to end in a 1, so I know it's not that. If I try 22 squared, that's going to end in a 4, because 2 squared is 4. 23 squared is going to end in a 9. 24 squared does end in a 6. However, if I try this 24 squared, it gives me a 576. So you do have to check it. So it's not that. 25 squared ends in a 5. 26 squared could also end in a 6 because 6 times 6 is 36. And this is the winner. 26 squared is 676. So that's how I know that my answer is 26. All right, here's your assignment for lesson 3.5. If you want to get started on it, you don't have to. You're going to work on it during class tomorrow. But here it is, page 114 to 115, numbers 1 to 28, 32, 34 to 41, 46, 49, 51, and 52.